Okay, so we're going to solve some problems now using both the product and the quotient rules. And we're going to focus right now first on our product rules, and we're going to take the derivative of one function at a time as needed. So here at number 1, we have y is equal to parentheses 3x squared plus 2, close parentheses, times parentheses 2x plus 1. So you could go ahead and distribute this, but we're going to go ahead and use our actual product rule. And so the derivative of our first term, we're looking at our first term being 3x squared plus 2. That's going to be our f of x. And our 2x minus 1 is going to be our g of x. All right? And so if we go ahead and take the derivative of the first term, we end up with just 6x. And we multiply that according to the product rule by g of x, which is 2x minus 1. And we're going to add that to g of x, which is f of x, which is just 3x squared plus 2, times the derivative of g of x, and g of x is 2x minus 1. We're going to multiply that by 2. We're going to go ahead and distribute through, and we have 12x squared minus 6x. And we're going to add that to distributing the 2 through the second portion, 6x squared plus 4. And we're going to end up with 18x squared minus 6x plus 4. All right. And so again, if we want to go ahead and find the derivative of a function where it's two polynomials or binomials being multiplied by each other. So we have 5x squared minus 1 multiplied by the 4x plus 3. And we're going to go ahead and take the derivative. Now, we're going to always consider our first term being our f of x. We're always going to concern our second term being our g of x. So the derivative of 5x squared minus 1 is just 10x. Remember, the 1 just disappears. And we're going to multiply that by our g of x, which is our second term, which is 4x plus 3. And we're going to add that to our f of x, which is just 5x squared minus 1, times the derivative of g of x, our second term, which ends up just being 4 by the nature of what it is. We want to go ahead and distribute and combine like terms. So we've got 40x squared by 10 times 4x, plus 30x, 10x times 3, plus 4 times 5x squared, 20x squared, minus 4. And when we go ahead and combine our x squared terms, we end up with 60x squared plus 30x minus 4. All right, so then we want to go ahead and look at finding the product and find the derivative. Now, we have a function that's y is equal to 2x minus 5 quantity squared. Remember, when we have a binomial in parentheses, that means we need to go ahead and take that binomial and multiply it by itself. So when I have 2x minus 5 quantity squared, that means I need to take 2x minus 5, multiply it by 2x minus 5. Now I could go ahead and consider the power rule and take the derivative of the first 2x minus 5, which is just 2, multiply it by 2x minus 5, and add that to the g of x, the second 2x minus 5, again by the derivative of that first piece. And I end up with 4x minus 10 from the distribution plus 4x minus 10. And therefore, combined like terms, I need 8x minus 20. Now, is there another way to deal with this when we have repeated binomial functions? Yes, but we're going to talk about that a little bit later. Right, so let's look at example 4. Example 4 is we want to go ahead and take a rather complicated function. So we have y to the negative 1 plus y to the negative 2, close parentheses, And we're going to multiply that binomial by another binomial, 2y to the negative 3 minus 5 to the negative 4. And the first thing you want to do off to the side is you generally want to go ahead, when something is this complicated, you want to take your first function, consider it f of x, and then off to the side just take the derivative of that function, just write it down. And then we also want to do the same thing for our second piece of this, which is our 2y to the negative 3 minus 5y to the negative 4. And we want to consider that our g of x. And we want to go ahead and take the derivative of that out to the side. And that'll help you make a few less mistakes. All right? And so when we take the derivative, we want to take the derivative of f of x, which we would have figured out. And it's negative y to the negative 2 minus 2y to the negative 3 times our g of x, which stays the same, plus our f of x, which stays the same, and our derivative of our g of x, which is end up to being negative 6y to the negative 4. And it's going to be plus, because negative 5 times negative 4 is plus 20y to the negative 5. And then we got to go ahead and do all the distribution for that. And we end up with negative 2y to the negative 5 plus 5y to the negative 6 minus 4y to the negative 6 plus 10y to the negative 7 from the first piece. And then we're going to go ahead and add, but we end up with a lot of negatives, so we're going to see a lot of subtraction. And we have a negative 6y to the negative 5 plus 20y to the negative 6 minus 6y to the negative 6 plus 20y to the negative 7. Now we have a lot of terms that are going to combine here. We have a negative 6 to the negative 6y to the negative 5, and we're going to add that to negative 2y to the negative 5, which ends up with negative 8y to the negative 5. Our negative 6 terms, we have negative 5 y to the negative 6. We have negative 6y to the negative 6. We have plus 20y to the negative 6. And we have a minus 4y to the negative 6. When we add those all those four terms together, we end up plus 15y to the negative 6. And we have a couple terms that are y to the negative 7. So 10y to the negative 7 plus 20y to the negative 7 is equal to plus 30y to the negative 7. All right, so now let's go ahead and explore some problems using the quotient rule. So remember, the quotient rule is when we're taking the derivative of two functions divided by each other. We have a derivative of f of x times g of x minus the derivative of g of x times f of x over the derivative of g of x squared. So if we go ahead and use f of x, we have 6x plus 1 as our f of x, 3x plus 10 as our g of x. And we're going to go ahead and take the derivative of the top. So 6x plus 1 is 6 times the bottom minus the derivative of the bottom, which is just 3 times f of x, which is 6x plus 1, divided by the denominator 3x plus 10, and we're quantity squaring. So when we go ahead and distribute this, we have 18 x's and they cancel out. And we add plus 60 minus 3, which is end up with 57 over 3x plus 10 quantity squared. And there's nothing we can do to go ahead and simplify that. Let's go ahead and look at another derivative. So we have 5 minus 3t over 4 plus t. And remember, the top is always f of x, so the bottom is always q of x. The derivative of top is negative 3. So we have negative 3 times g of x, which is 4 plus t, minus the derivative of the denominator. Now the t is just, the denominator becomes 1. and it's going to be multiplied by f of x, which is 5 plus 3x. And when we go ahead and distribute, we have 12 minus 3x minus 5 plus 3x. The 3x's cancel, and so we end up with negative 12 minus 5, which is negative 17, over the denominator 4 plus t squared. Right, the last problem, if we're going to go ahead and take y is equal to 4t squared plus 11 divided by t squared plus 3. Again, we're going to go ahead and take the derivative of the top, which is 8t, times the bottom, minus the derivative of the bottom, which is 2t, times the top, f of x, over the denominator squared. And again, once we distribute, we're going to have 8t cubed plus 24t minus 8t cubed minus 22t. And the negative 8t cubed and the positive 8t cubed are going to cancel. And we're going to be able to combine our t terms here, which is going to be 2t. And it's going to be over the denominator squared. Right. Again, we're going to go ahead and look at the derivative here. So we have g of x is equal to x squared minus 4x plus 2. And that polynomial is divided by x squared plus 3. So go ahead and take the derivative of the top, which is our f of x is 2x plus minus 4, times the denominator, x squared plus 3, minus the derivative of the bottom, which is 2x, and our times our f of x, which is x squared minus 4x plus 2, over our denominator squared. When we go ahead and FOIL, we get 2x cubed plus 6x minus 4x squared minus 12. And then our second piece, remember that negative has to distribute. So we're going to be negative 2x cubed plus 8x squared minus 4x. And it's going to be divided by the denominator squared. We're still not messing with that. Our 2x cubed are going to cancel. From there, we just go ahead and combine like terms. So our negative 4x squared plus 8x squared is going to be plus 4x squared. Our plus 6x minus 4x is going to be a plus 2x. And our minus 12 is going to stay because there's nothing else to combine it with. And we're going to leave this just as it is.